Okay, so we're back. This is example number 4, and in this one I have a square root and I have some trigonometry functions mixed in, so keeping it interesting. I notice that I have a cosine and I have a sine, and again my two hints for which is u is going to be the one that's in the most complicated position, and I think by far 1 minus sine x wins that competition. But also if I take its derivative, and in this case the derivative of negative side would be negative cosine, and it appears. Now, I know it's not a negative cosine, but the negative is not a big deal. I can take care of that. It's the fact that the cosines there is important. Now, if I take the derivative of cosine, I do get sine, but again, since sine is in a more complicated position, I'm going to go ahead and pick this guy. So u is going to equal 1 minus sine x. And in tutoring earlier, somebody asked me, why not pick the whole entire cosine, the square root? And the reason I don't want to pick the square root is because when it gets time to take the derivative, it's going to be a really complicated derivative using chain rule. It's not going to give me a nice cosine of x dx. So I don't really want to do that. I want to do 1 minus sine x because I can already anticipate that when I do the differential, I have to take the derivative, and so the derivative would be negative cosine in this case of x dx. I get something real nice, cosine of x dx, which is what's here. Okay, so that's the reason I don't want to pick the whole entire square root. Okay, so back to this again. I told you in video 2 that if you have ever a division problem, it's always helpful to sort of separate it. So that's what I'm going to do here. I'm going to have a 1 over the square root of 1 minus sine x, and you know that's going to become u times cosine of x dx. And this is totally legal because if I were to multiply it out, I'd get the same expression. As I said earlier, this thing down here goes away because we already said that it's supposed to be u, so let me just go ahead and call that u. Now, I'm getting ready to replace that cosine x dx because, again, we cannot have u's and x's, but we can't just do random replacement of u's and x's. We have to do it legally. And so du is equal to negative cosine x dx. Well, that's not exactly the same, but almost. Technically, this is a negative 1. If I divide both sides by negative 1, what I'm going to end up with is a negative 1 du equals cosine of x dx. And that's good news because now I have cosine of x dx exactly the way it shows up in my integral. So what that means is I can replace that cosine of x dx. All of it can get replaced with that negative 1 du. So going back to rewrite everything, I'll have the integral. I'm going to go ahead and do 2 steps in one. I'm going to take this u to the square root of u, which is in the denominator, and I'm going to go ahead and write it as u to the negative 1/2. And now cosine of x dx gets replaced by negative 1 du. As I said earlier, you can simply take the negative 1 out, and I have an integral of u to the negative 1/2 du. Okay? So we're now just going to go ahead and focus on taking the antiderivative of this piece right here. And we can use that rule of adding 1, multiplying by the reciprocal. In this case, I'm going to get 1/2. If I multiply by the reciprocal, that would be a 2. So in the end, I'm going to get negative 1 times 2u to the, let's see, 1/2 plus c. Don't forget the plus c. So of course this will become negative 2. And last step, don't forget to replace u with what you set it equal to in the beginning. In this case, 1 minus sine x. So let's see, negative 2 times u to the 1/2, same thing as the square root of 1 minus sine x plus c. And that's it. Alright guys, hopefully you guys are getting more comfortable with the process and it's making more sense. Alright, the last example I'm going to go over in the next video is going to be this example here set up by, it's an actual AP problem. So go ahead and watch that one, so check it out.